Welcome, I'm Blue Dolphin with the Hoplite Security channel, and we're going to be getting into another Pico CTF challenge from the forensics category. This is going to be tunnel vision for 40 points. Let's get into it. Jumping right into things here, I've already downloaded the files, so let's go ahead and take a look. And we'll just start by running tunnel vision on it, and we can see that it is a data file, so let's just run head on the file to see what comes of it. Nothing. I guess there's a BM at the start here, which could maybe suggest it's what is it, a BMP or a BPM, the bitmap file? I'm not sure though. Let's go ahead and just try running strings on it and see maybe there's just a quick win here. I did see one long string. Maybe that string will be, I don't think it's going to be anything. Let's just grep for the flag, grep Pico. Nothing. Let's run tail on our file. That's not helpful. We can run bin walk, I guess, on our file. It says it's a troc. I have no idea what a troc file system is. Let's just take a quick look. Troc file system. Someone else is saying they did this as well and they had no idea what was going on. Troc file system. Yep, this looks exactly what we have. And here they're saying, oh, use the, because we want to pull out raw data. So we're going to use the dd command, I think it is. If not, just comment down below. Let me know. Binwalk --dd equals dot. I don't think that did anything. Then you can extract everything by that. Okay. Oh, let's take a look, I suppose. Not sure if this actually did anything. Let's go ahead and open up a file here. Jumping into our PicoGym, our extracted folder. So these files, I'm just not seeing really anything there. Let's take a look. Let's run head on these files just to pull the headers. That's not helpful. Trocawaka. This just looks like garbage. I guess we can run head on the next. Yeah, nothing again. Okay, let's go back and try changing it, I guess, to a BMP. Let me remove the extracted file. Actually, maybe not. So let's go copy tunnel vision to tunnelvision.bmp, I guess. It just says, yeah, I don't think that's, oh. I think we're actually gonna have to open this to view it. So let's go ahead and open up our directory, jump over to the PicoGym here. Opening a folder where the files are, we see we have the regular tunnel vision file, can't even be opened. Neither can the BMP one, but I wonder if we should have to change it to BM. Okay, so we might have an issue with the hex data here. So I think we can just use ImageMagic. I don't know, is that even on a computer? Not found. I'm gonna try something. I'm gonna try a shot in the dark. Let's do sudo apt install. And if you don't know, ImageMagic just helps with resizing and in some cases repairing images. So we'll do sudo apt install. I guess I don't have to do the dash. Install ImageMagic. All right, let's just Google how to do this. Linux ImageMagic download. You can see here we have the website. I guess Linux binary, sure. It's weird we can't do like pip3 install ImageMagic. Huh. I bet you I'm just doing something wrong here. Okay, so we have our downloaded files. Let's open this up. Run the, I guess let's try and run it from the command line here. There's our magic file, so we'll go, we just run it. Oh, sudo apt. Would it be sudo dp? Let's just do sudo apt. Oh, you know what? I have to do ImageMagic, I think. Oh, I spelled it wrong. Image. It's hard to think, talk, and do CTS at the same time. There we go. Okay, so now ImageMagic is installed. Installing. So let's try ImageMagic. So that didn't quite work. I guess I'm just looking at a guide, how to use magic. Okay, so it says we have to just, that doesn't make sense to me. Magic. Interesting. I don't think this installed the way I thought it would. What am I doing here? I'm just trying to think why this isn't working. I'm not actually sure it installed properly. Oh, we can do magic version. So I guess it's suggesting we just try magic, but I don't think, yeah, that's not what we want. Oh, okay, I think we do display. Okay, there we go. So now we have, oh, sweet, awesome. Okay, so let's, I guess, open this file then. You can see there it is. It's the magic file. No decode delegate. Elf. Oh, you know what? I think we have to, we have to open the BMP. That's the issue. So we're in the downloads folder. So let's go up a folder, jump into home, Kali. Let's see here. Oh, no, that didn't work. Let me close that. Let me actually just jump into the target directory, which will be Pico Gym. And then let's open magic from here. Oh no, it's display, isn't it? Yeah, there we go. Okay. So now we'll try opening this again. And then if this still doesn't work, I think the next thing we'll do is we'll check the hexadecimal data, also known as the magic numbers, which is the data at the start of any file that defines what type of file it is to the computer. So let's first try opening the regular file. Oh, okay. I guess I didn't need to change the name. It just works just fine. So it says not a flag. Sorry. I feel like it's kind of a oddly wide image. Let's do that again, but open up the BMP version. File open. No. Let me change that to BMP actually. From here, we'll open up that BMP file and nothing. Interesting. So let's take a little look at the metadata. I'm just thinking, yeah, let's take a look at the metadata of this file. So it is indeed a very wide file based on the resolution there. We have the height, the width. I think one thing we can do, because we know it opens, is we can try changing the height. I'm just trying to think how to do that. BMP image change height. I think we can do it with the hexadecimal by just altering the hexadecimal information within the BMP image header. So let's take a look at this article here. And they're just simply asking, how do we do this? Yeah, it looks like it's definitely possible. Okay, so it's possible. I know it is. I've done it before. Let's just try using ImageMagic. I wonder if the edit function would actually let us do this. Like, what if, no, it's not. Transform, maybe? Trim edges. No, it's not going to. Let's do, let's see, do I have the hex D? is that HXD? Okay, so we can install HexD somehow, which is a hexadecimal editor. We could also use Bliss if this doesn't work. Yeah, or it's either Bless or Bliss. It's Bliss, okay. Let's go ahead and open up that file. Here's our, that's a 2.9 megabyte file, so I'm pretty sure we're gonna find the flag here if we change things up. Not a fan of this, but let's just take a look here. So let's look up the header information. And usually you'll change the information within the header, within the hexadecimal of the header. So we can go BMP header magic numbers. And again, the magic numbers are just, that's the hexadecimal information that defines the image in a sense. And this is a list of, so we don't want a list of file signatures, I don't believe, because, well, let's see, we can probably storyboard bitmap. I'm just thinking that's not what we want. Form IFF intro. Nope, we don't want this. There's a lot of BMs in here. BM bitmap file. It's the most used in the Windows world. Okay, so it's supposed to start off with 42D. Yeah, we get that. Let's go ahead and we just want to find out all the information within the header. So we have, pixel storage. What's this? Size, width, height. Okay. So the image pixels are generally stored with a variable number of bits per pixel, which identify its color, depth, and everything else. Wonderful. So now we want to identify which of the hexadecimal bits are our target for editing. I'm going to search up BMP file header hexadecimal to see if this is it. Oh, this is looking, yes, we want the structure. I guess that's what I should have searched up, is structure. That's really hard to read. That's not ideal. Oh, this is better. What are we looking at here? Bitmap file header, DV header. Oh, okay, so I think image height is just going to be the next chunk in the image. So if we take a look at our bless, I'm thinking, I'm not liking the structure here. I'm actually just going to install hexd. I'm kind of confused. Let's go hexd install Linux. Hex editors on Linux. Perfect. Oh, I guess there's XXD as well, but I really want hexd. It's my favorite. We could probably just do this in Windows where I do have hexd. And that's just going to be the easiest thing to do. All right, and let's open this. Okay, let's pivot here and let's see how this goes. So I'm just looking here at the offset, and I'm just going to try and walk through here and overlay this so you, the audience, can see what's going on here. Let's shrink this window down and work through this. So we can see that our file should start off with a BM, which we already know it does, and that's going to be 2 bytes. Then we jump into 4 bytes, which will be our header. We can see here the BM. Then our next 4 bytes is reserved, and I guess if it's unused, it's 0, which we see everything is 0 here. So then this next part is the data offset, which is the offset from the beginning of the file to the beginning of the bitmap. And this is reading as BADO 000 Okay, let's count here. So we have, so our offset is supposed to be for the height 16h. So we'll start here and we're going to count in. So starting from 10, we'll go 11, 12, 13, 14, 15, 16. So this should be our height, but we can change it to 2. This might not go well. And we'll save this as something else. We'll save it as, okay, let's actually, I'm going to pivot over to the Linux terminal here because I don't feel like installing, what's this? Oh, hex editors. Okay, that was weird. Let's go back to that file there, the PicoGem forensics. Let's do PicoGem forensics, and let's run bless on our target file. I'm just thinking here. Okay, let's open this up and make the offset change here, and then use ImageMagic to open it up. So our offset here will be 12, so 14, 15, 12, 13, 14, 15, 16. All right. So we'll take this bit here. Let's make this a 2. Oh, no. Nope, not a 3, a 2. There we go. Let's save this. I feel like that didn't save properly. And let's just try display. I wonder if we can just call the file directly. No, I didn't want the BMP version. Is this even any bigger than the previous one? I don't know. Let's see here. Let me just jump back over there. PicoGem in my directory, the forensics directory, and then let's go display. Slightly confused here. Oh, I see. Okay. So that to me does not look like it worked. I guess we can just try making it a little bigger then. Or perhaps Bless didn't actually edit the file. Let's edit the BMP version. Try this again. Change this 1. To like 4, I guess. And then I'll do a save as because I'm not sure. I don't think it actually saved here. So we'll go forensics under Pico CTF, and we'll just call this test.bmp. I'm going to open up another terminal here. Perfect. And we'll go display test. That's not a good thing. It didn't open. So it says static planes is not equal to 1. I guess what we can try then is what if we just try dropping down? I think we're kind of, no, it says here static planes. Okay, let's try changing it to 2. I somehow think I'm just off the beaten path here. Oh no, I just think I destroyed that. Let's undo that. Let's make that a 1, save it. Let's see, I don't even know if it's going to open this way. Yeah, no, it has the same issue. So there's another issue here. So let's go display tunnel vision. And okay, so that one's working. Let me remove this test.bmp. I'm not a fan. Let's make sure display is opening the test.bmp. Okay. And then what I'll do is I'm going to instead open up tunnel vision again. And we're going to try this from the get-go. So we're just looking at the information that suggests where the height is, and the height being suggested is obviously, oh, I think it just closed on me. Offset 16. Let's just change this again. And now let's save this. I'm just going to keep it in the same file. This is the .bmp version, and I'm going to open it. And it still has the issue static plane's not equal to 1. But perhaps I am just confusing myself. I think I just have, yeah, I think I confused myself. So if we go, so we count from this offset at 12, 13, 14, 15, 16, and this is where it's supposed to begin. So then I believe this is going to be a part of it. So maybe it's this number, because the 32, let's change this to a 2, and then see if that works. I think I was just, no, so again, it says that we have an error because a value doesn't equal 1. And then I'm just thinking this doesn't have to be bigger. Like, what if we make it a 4? Nope, still no dice. 32, I'm just thinking 32, what would 32? Oh, brutal. All right, I think we're close here. Let me just remove. Let's try this again. Let's do bless tunnel vision on the regular file. And I'm just wondering if I'm getting my offset wrong. 12, 17. I think if you worked in forensics, this would be a lot easier, but I'm thinking that okay, so this is where it begins. So then we should be able to just increase. Oh, I can't seem to edit it. There we go. Oh, should have the old numlock there. All right, so I'll add, we'll make that a 4, and then we'll just try seeing if this works. Dang, nothing. Okay, I've just re-downloaded the file here, and we're just going to open this with bless. So then let's count the offset again. I was confusing myself. It's going to be 13, 14, 15, 16, and then the offset begins here at 17. So we have a 2 there. So let's make this a 4 and see what happens. Otherwise, I think I might take a different approach here. Or just, yeah, let's see. So we have a new error. It says insufficient image data in file. Because we're dealing with resolutions, we shouldn't have to put in a large number here. It should just be like 1 or 2 points higher. So let's drop down 1, and then we'll try 2 if that doesn't work. Oh, that's weird. It worked. Huh. Okay, well, let's go ahead and enter that. Make sure this is... Ooh, only 5,000 solves. I have to admit, I think there's... I'm not sure why I'm struggling with this one so much, but there's definitely a struggle. It'd be very unfortunate if this was actually a red herring. Very unfortunate. Okay, so we got the challenge. That's it. That's a wrap. See everyone in the next video.